Alrighty. So sure. So I guess some questions become what quantities are fixed here?
Well, we're guaranteeing what the angle on the two sides, but that also fixes everything else, right? This is another fixed triangle.
To fix everything else.
Yeah, I think it does, right?
Okay. Um okay. So it results in other things being fixed. I
Right.
got you. It results in other things being fixed. But yeah, we are fixing two sides and an angle. Whereas in the previous one, we only had, or not only, but we had three sides that were fixed and controlled. Um, and why in this particular case, as we start comparing it, we think about comparing it to the last one, is there not like a second reflected triangle that's pairing? Now, why does that not happen?
In this case, we do only have one circle.
Hmm. Does that matter?
I'm not sure how much the circle matters as it is. I'm not quite sure what the circle's for in this image, or in this scenario.
So the circle is guaranteeing that um the distance is measurable to side to find that intersection between what's going on between CA and AB. Um that's going to determine whether these things are actually intersect. Um so it's giving me that distance. And so we don't know what the distance is between C and B, what the distance A is. But we do know that the ray AC and the ray AB have to have the segment between them, and that's being formulated by that circle there. Um, when we start to speak to is there going to be like a second point of intersection or a second circle? The way this is different is that the segment of, in this case, A or BC, the segment BC is not a fixed distance. Therefore, I can't just arbitrarily make it anywhere. It has to be the connection between these two rays, BC and I'm sorry, AC and AB. It has to be that connection between those rays. The direction of those rays is forced by a particular angle measure.
Right.
Um, because that direction is forced, or the distance, the angle between them is a fixed measure. Um, the segment that connects those two rays would become fixed at a particular place. It could not occur in the other direction, or that would be a different angle measure. Does that make sense? If I have this
I
angle
still
measure
don't.
going the opposite direction, that becomes like a reflected direction. I still only have one way that those triangles can intersect. So let's say that AC, that ray, was going down instead of going up.
Right.
That angle measure would still be 75. I can still only create one triangle with that ray going down.
Right. So it's still congruent.
It was, yeah, it was still
But
with this, yeah, it's still with the same triangle, but I could not have this configuration giving me two orientations for a triangle because I'm fixed on that angle measure.
no, I don't see that. I don't see how this you couldn't just have like you. This does give us two triangles, right?
It
We
does
could
not give
still
me two
have
triangles.
point. We could still have point D down at the bottom.
You cannot. The reason you could not is because the angle measure has got to be a fixed, that's a fixed thing. So that tells you what the direction is going to be. If this angle measure is going to be 75, this gives me a fixed direction for that particular situation.
I
Now, when you
mean,
start talking about going the other way, going like into in a clockwise
are we
direction,
saying that that would then be a negative angle measure?
I'm saying like the direction would be counterclockwise. I mean, clockwise. So you can call it. I mean, I'm not gonna say it's a negative number, because we wouldn't have a negative number as a angle measure, but the direction of that angle is going to be something different.
Mm,
And do you agree that we tend to measure angle measures going in a clockwise and a counterclockwise direction? That's how we measure angles.
sure.
Okay. So if that is the case, doing it in the opposite direction, yes, we can get another triangle, but we're no longer now going in the counterclockwise direction. We're going in a clockwise direction by doing something different
Although at that point, you're assuming that you're measuring it from the line segment AB,
from line
as
seven.
opposed to measuring it from line segment AC, in which case it would still be 75 and being measured in a clockwise direction, or a counterclockwise direction, rather.
So you're saying I'm assuming that I measure it from AB versus from AC. I move AC all the way down here. I get a 75 going the other way. And then that would not, hmm, should I say this? Because that's going to start breaking down that measurement of side A by going the other direction.
I mean, we could do this in calculator, right? How do I add an extra line, a point?
Okay, let's make this. Let's see here. Let's put a no, no matter. I want to more. I want to construct an angle. Where's it at? Angle with given size, leg, vertex. And instead of 75 in a clockwise direction. Hey. And the segment. This this measure. Measure, 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 measure. Can you see my screen? I don't know if you can. I
Yeah,
don't know
I
if
can
it's on
see
the
it.
slides or it's on the GeoGebra. You see the
Yeah,
GeoGebra?
yeah, I do.
Okay. So I did what you said. I made this such that it's a angle measure. It was a wire or gamma. I didn't name it. Goes the other direction, clockwise direction. And then this has the same measurement of B. I just measured this as opposed to said it was connected to B. So if this gets bigger, this doesn't really fix anything as far as what A is going to be. Um, this is starting to give me a single instance. Well, I guess if I made this actually kind of rotated with it. So B is 13, 12. This is no longer giving me a reflected image or a triangle. I guess like if I were to say where does this hit this circle, if I constructed this the same way, um, Well, like we can see, they're not the same. Um, if they were going to be the same, wouldn't they lie on the same? Let me make sure this is 13 as well. 13. There we go. So they're the same. Now this is 13. Now they're the same. This is 13. This is 13. This is 13. This is 75. This lies in your triangle. The difference comes into play with the idea of this um direction of angle measurement. Which I suppose starts getting to like this idea of this reflective type thing. Um, Let me get my points of intersection. I want this to be a ray. That way it'll always work. I'm gonna get rid of my. I'm gonna get rid of segment AB so I can have a ray down there so it'll always connect. That way I can move things around. Where's this? I want the ray. Um, Oops. And I want the intersection of the ray and the circle that that way no matter. Oh wait, I missed the circle. Hmm. Sect.
I think the trick would be to make a second circle centered around A.
You want a circle center to A?
Yeah, have a circle centered at A, and then C and D are the intersection points between the two circles, right?
Do you want to share your screen so we can see that? Did you do it?
I'm missing probably something. I don't have the lengths of sides. I need to permission to share.
Oh, I thought it was already on there. Share settings. Don't share my screen more. Oh, why are things different? I am not letting you share.
Nope.
Oh my goodness gracious. All right, let's see. This has now, it looks different. Host tools for share. There we go. Okay, can you share now?
Yes.
Okay.
Is angle alpha rounded somehow?
Yeah, your rounding is up. If you go to let's say go to advanced, you might be able to change that to well, no, not advanced. Where is it? Go back to basic. Let me look. Let's see. Angles there. Settings. I don't know. It should be if you go to just the screw and you could change your global settings, but in mine, what I had to do was in the algebra tab, I forced the rounding to be well, because this calculates just to one, there's a slider. It's only to it's no decimal places. It goes increments of 1 degree. So it's not going to show decimal places on that from the slider perspective.
All right, well, do we just get to make the assumption then
What's your assumption?
that these two angles are going to be equal at all times?
You have your C that you're controlling there. Method D is one. Okay.
So in this case,
So
we have a fixed triangle just like our SSS triangle that does
mhm,
also have the second mirrored triangle underneath.
mhm. So yeah, we have this reflective motion the same way we did with the side side side.
Yeah.
Oh yeah, I do agree with that. I do agree with that. I would say we don't normally emphasize that because the orientation of the angle typically fixed is typically fixed. But yeah, if we want to orient things or not have a fixed orientation of angle, then yeah, we can speak to reflection the same way from side
So
side side.
so we'd have to define the angle as specifically being angle BAC as opposed to CAB.
You would need to fix it to be saying that it's gonna. Well, yeah, I guess that you could say BAC in a clockwise, a counterclockwise direction, to make it be like how we normally orient angle measures. But yeah, so yeah, we have that other half plane in there by saying that we can have our angle measure going in either direction. Then yeah, that is very much true. Very true. But I would say typically we keep angle measures. So yeah, you got me. But yeah, typically we keep angle measure as being oriented in a fixed way. Um, by the way in which you measure it being like a counterclockwise direction. And based off the orientation of where things are located currently, it has to go one way. If we start to orient differently the two sides and then thus the angle, then we could create something different. Yeah. So you know you oriented the side AC on the bottom.
Yeah.
Okay. And so yeah, orienting those two things differently does would create a mirror image across that half plane there of the segment AB, that half plane. All right. All right. One more. One more. All right. Any word on the issue yet?
Nope, haven't got anything from him.
Hmm. Oh, Paul's all right. All right, so I put a new one in the chat. Um, we have the non-included angle case, and so I'm going to try to, or want to investigate this one. Um, so again, we'll have a few minutes to kind of speak to or just explore and look around. I'm going to think about when do the triangles exist? When do multiple valid triangles appear? Um, why do the measurements fail to uniquely contain a structure, or create one? Um, any kind of things that relates to geometric freedom, and how does this compare to the first two, which was your side, and your side angle side that we already mentioned. So I'll give us a few minutes to kind of mess around with that. We'll do another 3:30. Alrighty. So, what is different here by comparison to the previous investigation?
So in this case, we have two potential triangles that can be created with a feature that is not the same, right? As opposed to just the mirrors, which still
Okay.
have all the same like key features. This one
Okay.
has an alternate that does not share a key feature, a or more.
Okay. So it creates, I'm just paraphrasing, make sure I don't say things off from what you said. It creates two triangles that don't share a feature. All right.
Right.
Okay. Two triangles do not share a feature. Um, does it always create two triangles that do not share a feature?
Um, no. There's the instance that I was trying to do, but couldn't figure out how to. I did it once. If where if both triangles perfectly line up. I don't have the conditions for it worked out, but the blue triangle happens to line up perfectly with the red triangle.
Okay. If you were to make let's see, where are you at now? I think I still see your screen. At 60 degrees, that's going to be difficult because you're going to start trying to enforce an equilateral triangle. Um, if you make it more of an acute, smaller acute one, you can start to generate your single triangle case. Let's say you have like a 45, it's going to be a red one, or 22 would be fine. Yeah, you can bring your C down. And keep bring your C down. I'll bring your A back up.
Bring the C down to making it farther away, right?
No, 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 it's fine. So what happens is you're starting to eliminate that second one being created. It's just coming down. It's either going to the right or to the left is how this is kind of built. The one on the right side is going to come down to take
Oh, I
over the
see.
all of them.
I was thinking something different.
Oh, okay.
I was
So
thinking,
you're trying to make the two triangles become one as opposed to
yeah,
getting okay. This is built such that you're getting rid of the first of one triangle versus making them become the same triangle.
right.
Okay.
I just refresh the page. I got it pretty quickly when I first started.
Okay. So, what can't happen? What can't happen now? So, what is kind of limited now?
So we've got our two lengths and the side or the angle that isn't between those two lengths.
Hmm.
Um, so we're constraining some of the things, but not this angle
Hmm.
and not this side length. Either of those were constrained, then we would have a fixed triangle.
Yeah, yeah. If we force those to be something different, yeah. I agree with that. So what had to happen for based on how this was kind of built, what has to happen for the second triangle to disappear?
It has to break that rule that we talked about earlier that the side along the side length has to be less than the summation of the two shorter sides,
Mm-hmm.
right? So if C was like 4,
Hmm.
right?
Hmm.
C and A are the shorter sides, so they would add up to 10.
Hmm.
And this extra side, it's got one instance where it is longer than that, but the other instance, the other triangle that would be created would be if it was pointed in the left direction, in which case this other leg would be the longest, and 4 plus the other leg that we don't see in this case would not add up to 6,
Okay.
if that
It's
makes
almost like
sense.
that C side gets so small that it no longer can generate or too so big rather that it can no longer generate this the inequality that needs to happen. Um well, small because it's down here. C side gets so small it can no longer generate the summation that you need for it to actually reach um to create a triangle.
Yeah. So the difference between the two triangles is what side length is the longest, right?
Yeah, yeah.
In the red triangle, the longest side length is the big top side.
Right, AC.
In the blue triangle, the longest is the side length equal to little c.
Hmm. That is true. That is true. Hmm. Anything else we noticed with this or want to speak to with this particular configuration?
Hmm. It does also have the same feature of the last one in that you could still create the mirror image below, but then if we constrain that the angle
Hmm.
has to retain orientation, then we wouldn't have that again.
Hold up. You're breaking up.
Ooh,
Still there?
I'm still here.
Oh, I can't hear. You still there?
Hello, hello.
Oh, is it my connection is unstable? I think okay, it says my connection was unstable. I heard you speaking, but it was like choppy, it was breaking up.
Hmm.
I think that's my connection. You want to say what you said again? I didn't catch it. I'm sorry.
So just like the SAS triangle and the SSS triangle, we could,
Hmm.
if the angle wasn't constrained with orientation, we could make the reflected triangle across a line of symmetry. And it would have all the same constraints, but wouldn't, yeah, we kind of already talked about it with the SAS triangle. You there? Oop, we back?
Sure. Yeah, yeah. It's like I heard you start talking and then it just goes away, and I think that must be me. So I'm like, I'm trying to catch it. Um, is it showing me? Does it have me freezing every once in a while? That was going on.
It did that time.
Okay, I'm over here trying to listen. I'm like all leaned in. Um,
I was just saying that it
which,
had the same features as the SAS and the SSS triangle, in that
hmm.
you could mirror it and it would still fit all the same constraints if you didn't specify the angle had to retain orientation.
Okay, yeah, 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 yeah. That's true. Yeah, if you reflect the image across the entire configuration across that half plane, you could still get a congruent triangle. That part is true. That's a very true statement.
And really, you could reflect across
Any side, yeah. Any other segments, any half planes that you of your choosing. Um, and you'll create that same thing with all things other things equal. Um, that's true. But then, like, I guess the important question is when we keep the given measurements fixed, does the geometry allow for more than one like non-congruent structure or not? Yeah, keeping all things fixed that we've given, does that allow for more than one non-congruent structure?
In this case, we say yes, because the blue triangle is not always the same as the red triangle.
Hmm. Yeah. And so, um, this idea with this particular situation is that within a single half plane, if we look at just one half plane of existence, and not think about all different ways of reflecting it across the segment lengths or creating different half planes, can the measurements produce two different triangles? As you already stated, I mean, you have up there, yes, yes, you can create two complete different triangles in the same half plane. Um, Everything about, reflection across the plane always, preserves congruence. Um, the thing we're speaking to here is do that measurements allow multiple non-congruent triangles before any reflection type things happen? And other than just the one or two, that's all we can get. We can get either one triangle or no triangles or two non-congruent triangles um, in that single half plane when we're given these ideas, these two sides and the non-included angle, right? But it is interesting to have the conversation about half plane orientation. That wasn't where this was going to go, but we're bringing it up, so hey, that's cool. Um, it's always good to have some to kind of deepen and refine conversation around it because I did not expect to speak to half plane stuff, but here we are. So I'm glad that you kind of brought this to the forefront that these things are taking place through reflection that we can have choose a different half plane to speak to. So we have these two triangles. They have different third side lengths, as we already mentioned. One will be either be the longest side or not, um, which is great. And make sure I got all my things to make sure we're good. And how does this compare to side, which was the first one? We had three fixed sides, and then we had two sides and the fixed angle between them.
I
How does this compare to that?
think it's difficult to say there's one definite way that they like that SSS and SAS have, but SSA doesn't have.
Hmm.
Not like one obvious feature. Like you can't say that it's uh, SAS has each like consecutive feature is defined because that's not really true with SSS because by those standards you would need the consecutive angles as well. You can't say that they each have three because three defined features because SSA also has three defined features and doesn't fit the bill. So I don't I don't know what it would be at one clear reason for why some work and some don't, other than it's just how it is.
So you're saying you don't have a way of articulating why side forces a single configuration, why side angle side forces a single configuration, and then why side angle side has multiple the potential for two different configurations of a triangle. Um,
Other than saying just it does, right? Like we could say side does constrain that. Side angle side does constrain that. Side angle doesn't. Just because you can find them.
okay. Um, so in the first two investigations, once the measurements were fixed, um, all the valid triangles had the same side lengths and angle measures once those two things were fixed there, which was not true in the side angle case, because the third leg um, varies. They vary.
Right.
Um, so in side to side, once the measurement fixed, could the triangle actually change shape? Um, I think that's the idea isn't any further than we recognize that the only way to create a triangle with those particular properties um, guarantee that there would be one instance of that. Um, because you cannot do it any other way. When you start thinking about the ways in which, if you're given this, let's start with side. If you're given this three side lengths, the only way to form a triangle is to connect those endpoints. There's only one way of connecting the endpoints of those three together. You can't do that differently. If I have three pieces of string, the only way to do it is connect the endpoints. That's it. That instantaneously starts to fix things. You agree with that?
Yeah.
Si Similarly, with side angle side, if I have two again, I had two pieces of string or spaghetti, and I connect them in some type of angle measure. The only way I can create a triangle is connect the endpoints of those two pieces that are the two endpoints that are still free. That's the only triangle that can be created. There's nothing more that I can do after that. It forces the third side or the other things to be fixed. Do you agree with that?
Yeah.
The difference that I think starts to pop off with this one is because you have a side and then you have some other side, and then you don't know how they're connected to one another. Like these two things aren't connected to anything, and so you have this dangly issue that's taking place. Like I don't know what's happening to where, you know, if this arm is supposed to connect to this arm and this thing kicks down this hand because this thing it dangles, and I guess I can hit over here, or I can hit over here, because I can just swing either way. Creates the possibility of multiple situations taking place because it doesn't fix anything, because things aren't connected. Really, that's the why this is happening. The the three instances, the three measures that we're given don't connect the three pieces of information that we have. Like they're not connected at all. Um, because they're not connected, it doesn't force the triangle to be anything. It doesn't force a triangle. It allows for some ambiguity, because they're not connected ideas. Like in side to side, they're all connected. In side angle side, they're all connected. Um, side angle, they're not connected at all. We have no idea how those pieces connect together until you start trying to force a connection, and that starts to give you either a triangle, no triangle, or two triangles. That starts to make the difference. How these pieces are kind of working with one another. And in the case of side angle, they're not really working with each other at all as far as what we're given. They're not because they're not connected pieces. Um, and it's difficult to get a unique structure without the structure being connected. So like that's what starts to happen there. We don't have a connected structure from the foundational level. Therefore, I can't uniquely determine anything because I don't have a structure from to jump to start off with. That kind of makes sense?
Yeah.
All right.
It's just the problem of you can always ask why, right?
Hmm.
You can ask why in response to anything. I don't think you could ever get to the end.
That's true. That's true. We could always continuously ask the why. Um, but I think, this idea that that third vertex was either getting fixed or was getting just kind of like free. In the side angle, that third vertex is becoming very free. Nothing fixes it the way it does in side and side angle side. Because really we know all three vertices in side and side angle side. We don't even know at all anything about that third, but that's kind of where it's taking place there. All right. I want to share. All right. So you see my screen now?
I can. Yeah,
Okay.
I see the
All
slides.
right. Um, so yeah. So in this, the ideas of constraint is what's kind of forcing situations and um two, that should say three. That's my bad. That should say three, because obviously I can't count to three. When I had these three distances constrained, then obviously with the reflection and whatnot did allow for that kind of freedom. Um, Through our discussion about these half planes, with changing the orientation of our angle measure, yeah, we can speak to. I can revise this to kind of go with what we kind of spoke to. Um, so we think about the fact that we can look across our half planes and change the orientation, which does differ from, I have written on here like, distance and orientation are fixed ideas. But if we don't fix the orientation and we allow for it to be oriented the other direction, then yes, we can have reflection across half planes. I agree with that kind of conclusion there. When I have that non-included angle, my constraints are very much incomplete. I cannot determine exactly where that third vertex is going to be, and then I could get multiple valid triangles in this particular that instance there. All right. So what we'll do is we're gonna take a little break. Probably gonna end early because we don't have all of our partners. Hope I really do hope everything's all right with Asia here. Um,
Hmm.
that's odd. Um, but yeah, we'll take 10 minutes and then we'll come back and kind of have a brief wrap up. I mean, super brief because it's just us two, and the wrap up is just what you've already talked about. Since it's just you. And, and then kind of like call it an evening. All right.
All right.
So 10 minutes, we'll come back, brief discussion, and then some teaching things. All right.
Okay.
Alrighty. Um, so I'm going over the plan, and really, it was going to be a synthesis of us all together. Which you and I have done. And so it would not serve a purpose for us to just say it all over again to each other. Um, and so I'm not going to extend time just for time's sake. All right.
Okay.
So I will very briefly kind of summarize, and then kind of we'll just head on out. Um, but yeah. So early in the course, we focused heavily on constructing figures and dragging and noticing invariants, and today we shifted more towards asking when information determines geometric structure. Um, in the first activity investigation, the side lengths constrained contain the possible location of the third vertex, and so even though reflection placements appeared, the structure itself remained the same. In the second investigation, they included angle when you think about fixing orientation. So now look at the half plane idea. When we start to fix the angle, the orientation, it constrain the structure and remove that remaining geometric freedom um, of having this kind of nature if we don't deal with this half plane switching orientations. If you fix orientation, it removes that kind of freedom of being able to have it on either side um, of the half plane. In the final investigation, we saw that like the measurements were no longer fully determining a triangle. The geometry allowed for different structures to satisfy the same conditions, and I think the important takeaway from that is not necessarily memorizing congruence criteria, but the deeper idea is that congruence criteria is they can describe when geometric conditions fully determine a triangle and when they do not. Um,
Mm.
And so next class, we'll begin to focus a little bit more on how can we justify and explain those relationships, why the relationships hold geometrically. And I think that's the question that you're speaking to today is like the why is this? How we get to the why, rather than just observing them dynamically. And so we'll attack that on Monday, which I think will be really beneficial.
Yeah.
Um, Before we leave, did you have like you said have not had a chance to kind of look at the problem set one yet? That is due on Monday. Um,
Right. I have not done any thorough looking
Awesome.
through it yet.
Okay, that's cool. But yeah, if there are any questions that kind of pop up between now and Monday, let me know. If you do get a chance, I'm gonna send Liz an email after this. But if you do have a chance to kind of speak with her, see how she's doing, um, so I want to make sure that all things are good for submitting that to me on Monday. Okay.
I know she has expressed her difficulty with this class,
Hmm.
um, but I don't feel like I'm having the same issues with this class, and I feel like it'd be better coming from her than from me.
Yeah. Yeah. And so yeah, we'll set that up so I can get a just a conversation with Liasia to see how things are going. But yeah, but no, if there's anything else
So Monday in person
in
at
person
3.
at 3.
All right, I'll see you there.
All right, see you then. Have a great afternoon
Goodbye.
and a weekend. All right, bye bye.
Have a good weekend.